Hi everyone, today we are going to look at NumPy. NumPy is short for numerical Python. It is fundamental library for scientific computation in Python. It forms the backbone of Python data science ecosystem and is essential for anyone working in the field like data analysis, machine learning, and scientific research. At its core, NumPy provides powerful n-dimensional array object which allows for efficient storage and manipulation of large data. The array object is foundation for many of NumPy's capabilities, including fast mathematical operation on array, linear algebra computation, and random number generation. We'll see random number generation, how it will help us to deal with uncertainty. One of NumPy's key strength is its performance. It's significantly faster than traditional Python list for numerical operations thanks to its implementation in C. The speed boost is crucial when working with large dataset or performing complex calculation. NumPy's importance in data science and machine learning cannot be overstated. It is used extensively in data processing, feature engineering, and model evaluation. For instance, many machine learning models heavily rely on linear algebra operations, which NumPy handles efficiently. When we build linear regression model, at the back end it is doing matrix computation. So that will be done by using NumPy and it's much faster. Its ability to perform element-wise operations, broadcasting, and vectorization allows for clean, concise code that is much faster and readable. So NumPy will help us with the statistical operations. Using NumPy, we can compute eigenvalue, eigenvectors, and that we will use in the computation of PCA. PCA will help us with the dimensionality reduction. Let's say we have very large data and we want to reduce the dimension of it. At that point in time, PCA will help us. NumPy's random number generation capabilities are crucial for simulation. So a lot of investment bank does stochastic modeling because in uncertain environment they want to see what kind of risk they are bearing. Additionally, its ability to handle missing data, perform data type conversion, and reshape arrays make it invaluable in data cleaning and preparation tasks. Array is similar to list in Python, except that every element in array must be in same type, typically numeric type like float or int. Array makes operations with large amount of numeric data very fast and generally much more efficient than list. So we are going to look at NumPy documentation now. We already talked about why it's efficient, how it will help us with linear algebra computation, eigenvalue, eigenvector for principal component analysis, random number generation. We already talked about all these things, and it's integrated with libraries like pandas, scikit-learn, and TensorFlow. We look at some code also. So here I am importing NumPy. Okay, I'm creating array called revenue data. Then I'm computing the standard deviation, and the data type, if I look, it's float. Now I'm normalizing data. What I'm doing is that I'm taking the record, then subtracting mean from that and dividing that by standard deviation. So this is my normalized revenue. Let's say this is stock price data. So this is an array. Okay, I'm computing the difference of stock prices. What is the difference between these two? And then I'm slicing my array, right? We can do slicing as similar to list. So I got the difference here and then divided by the stock prices. So I'll get the percentage change, which is daily returns. So NumPy has a range functionality using which you can create array of numbers, right? So this is my start, this is end, and this is step. So let's look at the documentation of NumPy. Okay, let's say you don't know what this function does. What you can do is that you can go on the documentation and read what exactly this function does. So I want you guys to use documentation extensively. So we talked about the stochastic, right? Stochastics mean random. I'll give you exercise where you will have to create random number. Okay, let's say your distribution follow normal distribution. If I give you mean and standard deviation, you should be able to create random numbers using NumPy, right? What I'm doing here is that NumPy random normal distribution, my mean is 0, standard deviation is 1. I want to create 100 numbers. So I got these 100 numbers, right? Now I am computing mean. See, it's 0 and the standard deviation is 1. So this will help us a lot. Okay. Then second, I want you to see the linear algebra module. So we talked about PCA, right? In that, this linear algebra module will help us a lot. NumPy dot linear algebra, right? So whenever you get time, just go on this documentation and see what all possible operations you can do. Cholesky decomposition, right? Then eigenvalue, eigenvector, single value decomposition. We'll see how we can compute the single value decomposition, right? And what all these concepts, we'll talk about that. Don't worry about it. Okay. So here what I'm doing is that I'm creating array, right? Then 2-dimension array. This is how you can create 2-dimension array. And you can access simply like a list. You can check the shape, data type. What I'm doing here is that I'm creating array of zeros. We'll see how we can do that. Okay, then once we look at this also, create an array with range of elements starting from 0 ending at 10. Step 2, using np.I we can create identity matrix. We'll see what is identity matrix. So I'm doing some basic operations here, then mathematical functions. I'm generating random numbers, uniform random numbers, normal random numbers. I just showed you how you can create random data for normal distribution by passing mean and standard deviation. And this is linear algebra module, right? Just look at the document of that NP linear algebra eigen A. If you pass that, it will compute eigenvector and eigenvalues. This is used in PCA, principal component analysis. Here are a few questions. Let's go back to our file. I'm creating NP zeros. I created 8 number and then I'm reshaping it. I want 2 rows and 4 column. Same for ones. I have created 18 numbers. I want 2 rows and 9 column. This is how you can do it. Let's say you have millions of record and you want to apply some condition. We can use np-var. What np-var does is that, so this is an array. What I'm saying, np.var a is less than 5, then return a, otherwise multiply a by 10. So what it is doing, whenever a is less than 5, it's returning 0, 1, 2, 3, 4, right? And then after that it is multiplying numbers by 10. Let's say these records are millions of records. So using NumPy you can do this much faster rather than using pandas there, right? So here what I have, temperature of city A and temperature of city B. I have created matrix. Okay, this is how you can create matrix by adding 2 arrays, right? Slicing and indexing is similar to list in Python. Conditional selection. So let's say wherever the temperature is greater than 25, you will get that here. And this is for statistical. So this is for statistical operations. We can compute mean, median, standard deviation, variance. In statistics lecture we are looking at all these things in depth. Percentile, right? Then correlation, covariance. Let's say you have question about any functionality. What you can do is that 2 question marks and np.cell. Then it will tell you what it does, right? And what things you need to pass and what will the output be. So then we are looking at cell. So what cell does is that, so this is an array. In rounded we can pass till what digit you want to round, right? NP rounded, I'm rounding those numbers, right? Cell means it will go to the lower number, right? Minus 1.7, so it is taking minus 1. Again for minus 1.5 it is taking minus 1. For minus 0.2 it is taking 0. But for floor it will take 2. Here it will take 2. Here it will take 1. So that's what sealed and floor means. Pi, you know, so the value of pi is 3.14. You have that in NumPy. Then e is irrational number. It's known as Euler's number. It is used in quant finance. We'll look at that. NP, where we looked at it just now, right? So these are all functionalities which are there. There is a lot in NumPy. We will see while doing projects. I'll give you some exercise and there will be solution also. Yeah, thank you.